Okay, obviously I had a stream crash again. So off camera I tried to get the debugger to run again. And what I did is just I retried to click on the play button for the debugger. And it magically works. As I said, I'm getting a bit frustrated with this IDE. Even though I like Visual Studio Code a lot, it makes things easy if it works. But if it's not working, it's really like a hassle. So yeah, sorry about that. This will create a few new parts in the YouTube playlist. But yeah. I just want to finish where I have left off. And actually I wanted to implement the export of the motion hypotheses before optimization and after optimization. But with the recent stream crashes, I somehow lost the motivation, to be honest. No, I think I will do. I will still do it, but yeah, I need to change this definitely. But I have no idea how to fix this problem with the IDE. Yeah, that's why somehow need to live with this bug or this behavior or this annoying the annoying crashes. But maybe I will find a solution. Well, anyway, currently we have this image. What I will do off camera, I will save this image. Probably as a PDF and a JPEG, and put it onto GitHub. And with that, the GitHub page will be updated. I will then push all the code changes as well that I did, and yeah. And I will stream. I will then. This will be the current like live stream part. And in the next part, we can then take a look at how we can visualize the motion hypotheses, I think. Okay, but let's continue. So we are still at the first breakpoint. I will continue. Now we are at this breakpoint where I wanted to put it here, but it's now here. Okay. So I don't know if it did break out. Maybe let me still continue. Okay, now we are here. Now we can see what iteration variable we have. So this I is 0, and this I is 0 as well. So after just one iteration, we break out of this loop here. So we did not even bother to try all the remaining tries, but actually are already happy with like the first try that was in this list. What I'm looking for now is where are the poses from the course tracker? Where are they saved? We have the course tracker here. Let's see what is inside of the course tracker. We have all the camera calibration and the inverse. We have an RMSE. So this course tracker is providing an RMSE, it seems. We have last residuals, which are 5, I think. So those values. We have flow indicators, which is a 3D vector, I think. Also the flow indicators. We have some buffers, inverse depth. ACC, accumulation. Okay, this is not helpful. PC color. Okay, so this is the point cloud data, it seems. Color, depth, and 2D position in the images. We have the number of points, 6,981. For this current... so the tracker contains those points currently, it seems. Okay, so we have a new frame. Here we have some world to camera. Some translation, which is the 0 vector. We have some camera to world and world to camera. Let's see what the translation is here. Also the 0 vector, which is unlikely, I would say, for the dataset that we have. Here's also the 0 vector. Okay, so I'm looking for the estimated camera pose from the course tracker. There's a state vector, which is quite large. What is this delta? Zero. Okay, here there are some values here in pre-cam to world and pre-world to cam. They are different to each other, which makes sense. But they are not inverse. At least regarding the factor, like the sign, they are inverse. But there are some subtle differences. which is okay. So they are almost identical, it seems. Up to some rounding errors. Now we have the null spaces, which I'm not sure what this is exactly. Null space. What was that again? Affine has one parameter or one value that is interesting. Scale has 3 parameters. And pose, does it have 6 parameters? No, it has a lot more. What was this null space again? Okay, not important for now. Frame. Here's the transformation camera to world. Let's open up the translation. This seems to be similar to the pre and then camera to world. Zero 003 037 positive. No, this is the inverse probably. 37 37 001 001. Okay, 226 226. Okay, this the pre-world to cam seems to be the same, like for an initial check now, seems to be the check as the TCW. So we can read the transformation probably from world to camera is the same as the pre-world to cam here. So this is at least one, one position less to check. What is this opti? What does this contain? The same values. The opti does contain the same values. Okay. So what I would do here, so after the tracking has been done, I expect the tracker to contain the new camera pose that the tracker that the tracker estimated. And now I want to get that. I want to get that. I want to get that in at the end. At the end I want to get the tracked pose, or I can also get it here probably already. But then if we break out of this loop, I will only have one camera pose. But I want to have all of the camera poses, the tracked camera poses. So I think I will need to comment that out. this whole block. And instead of having this block here, I want to have a block that will save out the estimated camera pose onto the hard drive. And I want to have the same code, more or less, for all of the individual motion hypotheses. So what I want to do in the next part is I want to visualize what is happening from the initial motion hypotheses, the 83 motion hypotheses, after they have been tracked in the course tracker. Let me quickly check if there's something else happening that will change the poses or something. Okay, and here somehow the pose is extracted. So we take the current frame and set its pose to cam to world inverse. And cam to world is last F. And where does last F come from? Oh, maybe it's above. Ah, last F, okay. Course tracker last ref. Course tracker last ref. I don't understand where the LDSO is taking the estimated camera pose from the course tracker. Here it is checking if this is the null pointer or if it's not the null pointer. But it's still setting the current frame to the pose of the last F, which is outdated, isn't it? Last F is still... it's probably a reference to... it's probably a pointer. Yes, it's a pointer. Okay. The bad thing is that I cannot try out to implement something because the stream will crash, which is a problem that will haunt me through the whole series, I think. but I can at least write the template code, or like this pseudo code, and then try to do it off camera, like to compile and test and so on and so forth. And then we can discuss it the next time. Okay, so to bring the whole idea home, what I want to do in this track new course is, first, when all the tries have been filled up, then I want to loop over all the tries. So in this part here, I will loop over all of them. And for each try, I want to create one file that contains all the tries. So let's make it a little bit more concrete. I want to have one file here, touch, which is called frame x underscore but tries, or initial tries dot text file, something like that. And I want to have a frame x and then optimized tries text file, like that. And both of them will contain multiple lines. So this is, for example, try number 0. And this will contain translation X, translation Y, translation Z, and then quaternion X, quaternion, you get the idea, quaternion Y, and also the remaining 2 lines W in this order. And I also want to have some notion about my RMSE, because this is included here, I think. But for the initial tries, what is the RMSE? Well, it's unknown, right? It's is it somehow initialized? No, this will probably be like a non or something, and not a number. Like this. Yeah, let's see. Hypothesis ID. So this is the hypothesis ID. And here is the RMSE, or residual, maybe something like that. Residuals. What else? Yeah, and maybe some other data like the flow vectors or something. So this is what I imagine to have for the current frame X. I'm imagining that I have multiple lines, like in total 83 hypotheses. And I do have the same for the optimized tries, like this. Where now for the optimized tries, I will have a value for the RMSE, I will have residuals, and I will have flow vectors that are actually calculated. And this is the goal I want to achieve for this part. I will start to write this code on stream, but I'm afraid that I cannot finish it while like the live stream is happening, because the live stream will constantly, every time I will try to compile or change everything or anything or write a line of code, the stream may crash, and this is just frustrating, not only for me but also for you as a viewer. And this is why I will do that off camera. I have to do it on off camera. I do not see any other possibility, to be, unfortunately, to be honest here. But still, let's discuss where I will put this. At what part, like on what line. So here I will loop over all motion hypotheses. Write to a text file. Here. What I will basically do is I will copy this for loop here